I'm Software Wala and I'm here one student at Rayhan School, Islamabad campus. So today I'm here with the new Maya. So today's my topic is about underrated innovations in modern technology. So let's start about today's Maya. First of all, call the Maya for some questions.
What's
Okay,
up?
so our today's topic is on underrated innovations in modern technology. So basic understanding. First of all, my first question from you is what is cloud computing in simple terms? So please give me answer on this.
Okay, cloud computing in simple terms. So basically, instead of storing your stuff, files, programs, whatever, on your own computer or server, you're keeping it on someone else's network of computers. Think of it like renting space in a really secure, well-maintained warehouse instead of building your own storage room. That someone else is the cloud provider, companies like Amazon, Google, Microsoft. They have massive data centers all over the world, packed with computers that are always on and connected to the internet. When you use cloud computing, you're accessing these remote servers through the internet to do pretty much anything you'd normally do on your computer. Things like OnePoint, storing photos and videos like Google Photos or iCloud, using email, Gmail, Hotmail, etc. 3. Streaming movies and music, Netflix, Spotify. 4. Running software, Google Docs, Adobe Creative Cloud. Even running entire businesses. Think of Salesforce.com for customer relationship management. What makes it so powerful is it's on demand. You only pay for the storage or computing power you actually use. So when I use iCloud to store pics and not photos, I get charged accordingly. If you start a business and get a whole bunch of customers on day one, you have servers there for those customers without needing to pay for any equipment before. That's totally different than having to buy your own servers ahead of time in anticipation of what might happen in the future. There are different types of cloud service as well. One, infrastructure as a service. You essentially rent servers, networking gear, storage, the basic building blocks for IT. Great if you want maximum control, but also need to manage everything yourself. Platform as a service provides tools and infrastructure for building and running apps. Developers love it because they don't have to worry about managing servers. 3. Software as a service. This is where you just use a complete application like Google Docs or CRM. Everything is managed by the provider. The benefits? Huge. Cost savings, because you don't need to buy expensive hardware or hire huge IT teams. Scalability, easily add or reduce storage. Software, capacity based on needs without being constrained by the limit of your hardware. Accessibility, access data from anywhere with internet. Collaboration, easier to share documents across multiple locations. And really, security, these big providers invest massively in security. But there are trade-offs too. Dependence on the internet. If your connection goes down, you're locked out of your data. Vendor lock-in. Difficult to switch cloud providers if you get heavily
So my
invested in
next
one
question
system.
from you is
Data security and
that
privacy.
why is good computing considered underrated? Please give me answer on this question. Let's start the answer.
Good question. Cloud computing gets overlooked in terms of how fundamentally it's changing everything because it operates behind the scenes so effectively. Most people interact with the results. Netflix streaming flawlessly, Google Docs being accessible everywhere, without realizing the incredible infrastructure making it happen. Here's why I think it's underrated. 1, it's the foundation of modern innovation. Think about the apps you love. Almost all of them are powered by cloud services. AI, machine learning, data analytics, they'd be impractical without massive computing power, which cloud provides on demand. Dramatic cost reduction for businesses. Before cloud, businesses had to invest huge capital in servers, IT staff, security, and maintenance. Now, it's pay as you go. Small startups can compete with large corporations because they don't need to outspend them on infrastructure. 3, accelerated development cycles. Developers can focus on coding and innovation instead of managing servers and system updates. Cloud platforms automate so much back-end work, meaning faster time to market for new products and features. Business resilience and disaster recovery. Cloud provides built-in redundancy and data replication. If your server room floods or catches fire, you can quickly restore operations from a remote backup. So powering remote work and decentralization. COVID-19 proved cloud computing could keep businesses running when people couldn't physically be in offices. This flexibility fundamentally reshaped how we work. I think people take cloud computing for granted because it's like electricity, essential but invisible. When everything works seamlessly, you don't think about the underlying technologies keeping things afloat. It's become normalized, but the impact is monumental. It's genuinely transformative at scale, which is why I think it's underrated.
Okay, so Maya, my next question from you is that how did people store data before the cloud, and what problem did cloud computing solve? Please give me answer.
Right. So before the cloud era, things were very different. Data storage was primarily done in a few ways. One, physical storage. Companies and individuals relied on physical media like floppy disks, tapes, CDs, and DVDs. Their files lived on something you could hold in your hand. Think about backing up your computer on CDs or transferring files using floppy disks. Two, on premise servers, larger organizations would have their own server rooms, physical servers stored on site that housed all their data and applications. This meant they were responsible for all maintenance, upgrades, and security. External hard drives. Individual consumers would purchase and rely on external hard drives and storage for backups and transfers. The problems cloud computing solved were huge. One, cost. Owning and maintaining physical servers is extremely expensive. IT staff, hardware, electricity, cooling, it adds up fast. Two, scalability. If your storage needs suddenly doubled, you had to buy more servers, install them, and configure everything. This took time and money. Cloud provides instant scalability. You can scale up or down with a few clicks. Data security and backups. Protecting physical storage from damage, theft, or disasters was complex. Cloud providers handle backups, data replication, and physical security. 4, accessibility. Accessing data from multiple locations was difficult with physical storage or on-premise servers. Cloud makes data accessible from anywhere with an internet connection. Collaboration. Sharing files and collaborating on projects was tedious and inefficient. Cloud-based storage allows for seamless collaboration. So, the cloud basically solved a lot of logistical and financial headaches for both individuals and businesses. It went from owning physical infrastructure to renting capacity when and where you need it. A way more effective model, really.
Okay, so Maya, my next question from you is how does the cloud actually store information? Please give me a very interesting answer on this topic. So let
Okay. You want to go deep on how cloud storage actually works? This is where it gets really fascinating. It's not like one giant digital warehouse where your data sits in one specific place. It's way more sophisticated and distributed than that. Data centers. First, picture massive data centers. Think football field-sized buildings filled floor to ceiling with racks of servers. These aren't just any servers, though. They're powerful machines optimized for storage and processing. These data centers aren't just randomly located, they're positioned strategically for access to cheap power, good internet connectivity, and often cooler climates for energy efficiency. 2, server farms and distributed architecture. Within each data center are thousands of servers, forming what's called a server farm. Cloud providers use what's called distributed architecture. This means your data isn't stored on just one server. 3, data fragmentation. When you upload a file, any file, the cloud breaks it into small pieces called fragments or blocks. Think of tearing up a document into tiny shreds. 4. Redundancy and replication. These fragments aren't stored on just one server. Instead, they're replicated multiple times across multiple servers, often in different data centers in different geographic locations. This redundancy is key. If one server fails, there are dozens of copies elsewhere. A good cloud provider might have something called a triple replication policy, meaning each piece of data is available on 3 different physical servers. This minimizes the risk of data loss and ensures high availability. 5. Erasure coding. Beyond replication, cloud providers often employ something called erasure coding. This adds even more redundancy but uses less storage space than simple replication. Essentially, it's like adding mathematical redundancies to the data fragments. It can reconstruct lost data fragments even if some are missing or corrupt. Virtualization and software-defined storage. Most of this is managed by software called virtual machine managers, which handle making the servers available for use by clients in the cloud. The software defines storage by creating a virtual pool of space, which simplifies management and allows easy allocation or reallocation of space based on customer need. 7. Data encryption. The real sophistication is how all this data is secured. Encryption happens multiple times, first when it travels over the internet, again when it's stored on the servers, and sometimes even when it's being processed. 8. Content delivery networks. For delivering streaming video applications or frequently used files, cloud providers use content delivery networks. These have servers scattered around the world, closer to your location, so the content actually gets served from the nearest server, which makes it faster for you. Now, what happens when you actually request data? Let's say you want to play that movie on Netflix. The software knows where those fragments are located and quickly grabs the pieces from all of those locations simultaneously and reassembles them for you while you stream or download the file. The whole system is designed to make accessing data seem instant, even though data is being reconstructed across multiple servers in multiple data centers.
Okay, so my next question from you is how often do we use cloud computing without releasing it? Please give me an interesting answer on this topic. So let's start the answer, Maya. I'm waiting for interesting answer.
You use cloud computing constantly without even realizing it. It's honestly baked into so much of your daily life. Here's what I think are the most interesting everyday examples. 1. Streaming services. Netflix, Spotify, Disney Plus. Every time you watch a movie or listen to music, you're using cloud servers to deliver that content. Your device downloads those bits in real time, instead of actually downloading entire files you keep saved somewhere. Social media, Facebook, Instagram, TikTok, all those photos, videos, and posts you see, they're stored in massive cloud infrastructure, not on their own servers. Each time you refresh a feed, you're pulling data from the cloud. Email, Gmail, Yahoo, Outlook. Your emails don't live on your computer's hard drive anymore. They're stored and managed on cloud servers. Online gaming, services like Fortnite or Call of Duty benefit from cloud services because they deliver online real-time multiplayer experiences to millions simultaneously, something you could get without cloud infrastructure scaling on demand. 5. Online shopping. Every time you buy something from Amazon or browse products on any website, you're interacting with cloud services that manage recommendations, etc. Video conferencing, Zoom, Google Meet, Microsoft Teams all run on cloud infrastructure that allows remote video calls to function without lagging, even if thousands of calls happen simultaneously. Maps and navigation. When you use Google Maps or Apple Maps, you're receiving real-time traffic data, directions, and location data from cloud servers. Smart home. Controlling smart lights, thermostats, or security cameras with your phone. It all depends on cloud servers managing connectivity and storing settings for all your home devices. 9. Online productivity tools, Google Docs, Microsoft 365. Every time you create or edit documents online, you're using cloud services for version history, collaboration, and data
Yeah,
backup.
we have.
Most of these examples don't feel like technology anymore. They just feel like normal tasks you do every day. Cloud computing is the engine powering them invisibly in the background, which I think is the biggest reason why it's so often underrated or overlooked. Hey there, you still with me? Was thinking about that cloud stuff. Pretty wild how much we rely on it without even realizing, huh? All right, what's on your mind next?
Okay, so my next question from you is how does streaming depend on cloud technology and how does cloud storage protect personal photos and videos? Please give me very interesting answer on this topic.
Great questions. Let's break this down. So, one, how streaming depends on cloud technology. Streaming services like Netflix, Spotify, YouTube, they're almost entirely built on cloud infrastructure. Here's why. One, scalability. Think about millions of people trying to watch the same show at the exact same time during a popular release. Cloud platforms can automatically scale resources up or down to handle that demand without glitches or buffering problems. Two, bandwidth. High quality video and audio files take up a ton of bandwidth. Cloud providers have massive networks with high capacity internet connections and content delivery networks that distribute content efficiently around the globe. Storage. Streaming services have massive libraries with petabytes of videos. Cloud storage provides scalable, reliable storage without the cost of physical servers. Four, transcoding. Streaming apps have to format videos to work with multiple devices and internet speeds. Cloud services can quickly and automatically transcode files and dynamically adjust streaming quality, which makes their experience better overall. Content delivery networks, I mentioned them before, but they're key. Content is stored on servers geographically close to you, so you don't have to wait for streams from halfway across the world. If Netflix is serving content from India to Pakistan, they will keep copies in Pakistan, so you don't wait. Two, how cloud storage protects your photos and videos. Cloud storage providers employ various security measures. Here's what goes on behind the scenes. One, encryption. When you upload photos to Google Photos or iCloud, it's immediately encrypted, meaning it's scrambled into unreadable code. Even if someone gets hold of those files on the servers, they couldn't decode them without the right key. Two, redundancy. Photos are replicated, making copies across multiple servers. This protects data even if there's server failure. Data center security. Data centers have layers of physical security, restricted access, surveillance, biometric verification, and robust power backup systems. Four, access controls. You control access to your photos and videos using passwords, two-factor authentication, and sharing options. Five, privacy policies. Reputable cloud providers have detailed privacy policies outlining how they collect, use, and protect your data. Regular security updates. Cloud providers are constantly updating software to address vulnerabilities and protect your data from the latest threats. You're still responsible for safe password practices, but most providers do an impressive job protecting personal files in the cloud. It's a much more secure option than local hard drives that could be damaged or stolen. You still there? Just checking in. Anything else you're curious about?
Okay, so my next question from you is would happen if good services suddenly stop working? Please be my interest.
I'm not quite understanding. Could you clarify that for me? Are you asking what would happen if there was suddenly a disruption to the internet or something else entirely? The name Kurt Jarvis doesn't sound familiar to me. Perhaps there's a typo there? Still here, ready when you've got a clear question for me.